Hi there, this video is about the cost effectiveness analysis, that is CEA. Basically, the cost effectiveness analysis is an alternative to CBA, which is cost benefit analysis. It is used in certain situations where the quantification of benefits is not clear. The policy arenas in which it can be extensively used is this set of sectors, that is education sector, health sector and defense sector, among others. Because in these sectors the benefits, they are usually in non-tangible or non-monetary terms. We talk about education, we talk about health, we talk about defense. The benefits coming from these sectors, they are usually intangible. So there are two characteristics of this kind of analysis, this extension of CBA. And this is applicable where one of the major benefits is not monetized. For example, in the public health programs, the major purpose is to save lives, and that will reduce the fertility risk. But it's not precisely possible to find out the number of statistical lives saved or their values, because that is a very difficult thing to do, and there is quite a bit of uncertainty in the future, and the assessment of the statistical life can be quite contentious and debatable. So what we can do is that we can still try to come up with some alternatives, and these alternatives are basically mutually exclusive projects. That is, if we undertake one of these options, then we cannot undertake the other, because that will be wasteful. Therefore, we call it mutually exclusive alternatives or projects, MEPs. Decision makers are unwilling to place a monetary dollar value to life. That is, it's very difficult actually to assign a dollar value to life saved, because life can be looked at from various angles. For example, the income that is earned by the individual throughout his life, or the utility the other people have from him, or for example, the dependence of people on that person. So life is explainable in many ways, and if we simply assign a dollar value based upon the income earned, that will be perhaps underestimation of something very precious. So this is one thing. Therefore, we can see that quantification or monetary value is not easily assigned to various benefits, that is a life saved, etc. There are situations where some intermediate goods have shaky linkages to the individual preferences. For example, the exact contribution of different types of weapons to the overall national defense is often unclear. We have various weapons for national defense, and how much which of the weapon is contributing to the overall national defense, this is unclear. So see, another thing is unclear, that is an intermediate good, that is weapon, and its contribution on the overall national defense, which is the final good. So what we can do is we can do comparison, and that can be in terms of their costs, because we want to minimize the costs while keeping the objective or the effectiveness constant. And the other way is to look at the effectiveness to maximize it, while the cost can be kept constant for all the alternatives. So these are the two ways of doing the CEA, that is to either minimize the cost while keeping the effectiveness constant, or to maximize the effectiveness while keeping the cost as at a given level. So this is one thing, that is the benefits, how they exist in the CEA. When we talk about the costs, they are quite usual, that is they are in financial and monetary terms, and we are using some sort of technology. And here technology is not necessarily related to some digital form. It is a policy alternative that we are talking about, that we can choose. and that is incurred by the government agency usually in these sectors. For example, a public health plan is basically a implementation of some cost, and the benefits they are also expected in the form of effectiveness. So now we can come to the analysis, precisely speaking, in the form of this formula. The ratio is calculated as explained earlier. This is cost effectiveness ratio because cost appears in the numerator and the effectiveness appears in the denominator. Now we have ECR, effectiveness cost ratio, where the effectiveness comes first and then comes the cost. Here the purpose is to minimize the cost while keeping the effectiveness at a fixed level, and here the effectiveness is to be maximized while keeping the cost at minimum. This is the per unit effectiveness and this is the per unit cost. Here the value will be 1 of the effectiveness for the sake of analysis, and here the cost will be equal to 1 for the sake of analysis as we go ahead. Currently we are focusing on CER, that is the cost effectiveness ratio, and here we are going to go into the details of it. We have already understood that the alternatives that we have, they are mutually exclusive, and this ratio will allow us to analyze the situation and allow us to choose the best alternative that we have, and we do not have the monetary value of the major benefit at least. So we can write it like this: CER, cost effectiveness ratio, cost and effectiveness. I shows the alternative, and it is comparable with the status quo as well. That is a situation where no alternative is used, no intervention is done. So I stands for the alternatives or interventions, and status quo is also there where no project has been undertaken. Now we come to the certain example. So in this we have costs in $1 million and we have effectiveness test score improvement. As you can see, it's not in monetary units. That's where the CEA is required, because the costs, they are in monetary terms, but the effectiveness is not. So there are 3 alternatives, out of which we have to choose one which is the most cost effective, and these are the costs. For alternative A, the cost is this, B and C have their own costs. The effectiveness is also given 10, 15 and 20 in terms of some scores. Now the CER, that is cost effectiveness ratio, can be calculated simply by using this formula that we saw before, cost over effectiveness. So here we are, 50 over 10, we will get 5. In the same way you can find these values. Now we can see that 5 is the lowest value, and that means that the value is actually 5 over 1, which means for 1 unit of effectiveness we will incur $5 million. Here for 1 unit of effectiveness we will incur $10 million, and here $15 million will be required for 1 unit of effectiveness. So this A alternative seems like to be the most cost effective because it is the cheapest way of getting 1 unit of effectiveness, and hence for all the required units of effectiveness. Now we can make a graph of this in order to better understand it. We know that we are dealing with the change in cost and we are talking about the change in effectiveness, and effectiveness is equal to 1. As you can see here, it is equal to 1. So this is the graph that will explain the situation. Here there are 3 lines, blue, green and some sort of red color is there, and here on x-axis we have the costs, and we have the effectiveness, and on y-axis we have the costs. And here you can see the value is 1 of cost. So if we draw a line, a perpendicular, it will cut the various alternatives. This is for the first project A, this is for B, this is for C. So this will cut all the 3 lines, the rays, and they will be leading to these points. For example, this for project C, this for project B, and this for project A. So you see, for 1 unit of effectiveness, $5 million will be required as compared to $10 million, as compared to $20 million. So you see, this seems to be the most promising because it is the most cost effective alternative. Project A, alternative A. So with the help of this diagram, we can understand the CER. In addition to the CER, we have a similar ratio which is quite useful, and it can help us to compare various alternatives and see that how an increment can benefit the overall situation. It is known as the incremental cost effectiveness ratio because it is going to compare the two alternatives, the two consecutive alternatives ideally, and see that how the incremental cost per unit improvement in the effectiveness will be there as compared to the next less costly alternative. We will see this with the help of example. Primarily, we should understand that I is showing the current alternative and J is representing the previous one. So if I want to calculate the incremental cost effectiveness ratio, this will be the formula. It is between I and J, that is current and the previous alternatives. The differential of the costs of the current and previous alternatives, and the change in the effectiveness between the current and the previous alternatives. So the incremental cost per unit of improvement in effectiveness can be found by using this formula. This is ICRA, ICRB, and ICRC. This will show the improvement once we move from status quo to project A. This will show the improvement in the cost effectiveness ratio if we move from alternative A to alternative B, and this will be for alternative B to alternative C. So we are 5, 20, 30 are the various values that are found. This interpretation can be done as we can see. $5 million will be the additional cost if we want to improve the effectiveness by 1 unit on average as compared to the status quo. So the journey from status quo to A will require $5 million for each unit of the effectiveness. And if I want to move from alternative A to alternative B, for each unit of effectiveness, I will have to incur $20 million. And if I want to move from alternative B to alternative C, for every additional unit of effectiveness, I will have to spend $30 million. So you see that this shows that this is the least cost when it comes to an incremental value of the cost effectiveness. Now the decision can be taken if we want to have more effectiveness for each unit of effectiveness, what will be the additional cost that we will have to incur. So this is another piece of information that can be useful for us. This is the table in which we try to calculate all these values. We have done this before, the cost effectiveness ratio. Here we will calculate the differential of the costs, and here we have calculated the differential of the effectiveness. You can see 50 minus 0 means as compared to status quo. In the status quo, there are no costs and there are no certain effectiveness from that. So it will be 50 minus 0. Here you can see 150 minus 50, that is 150 minus 50. 300 minus 150. Here 15 minus 10 and 20 minus 15. It was 50 minus 0 and this was 10 minus 0. So we calculated these values. Dividing these differentials, I will get the incremental cost effectiveness ratio. It is equal to 5 here, 20 and 30 as we have shown above. 5, 20 and 30. So this is how we calculate these values. We can also try to plot these and try to make some more sense of it. These three rays stemming from the origin are basically showing the cost effectiveness ratios. Here we are, CE ratios. This one is for A, this is for project B, and this one is for alternative C. We have made these rays before, but now we will make the incremental CER. This can be done by making this simple triangle. If we choose to make the incremental cost effectiveness ratio between project B and C, then we can simply make this triangle the right triangle by measuring the vertical distance and the horizontal distance and making this right triangle. This will show the change in the cost, as on y-axis we have the costs. So this vertical distance will show the change in costs. It is 300 for project C and 150 for project B. So the difference is 150. And for the project, the effectiveness for these two projects is 20 and 15, as you can see. So 20 minus 15 is 5. Dividing 150 by 5, I will get 30, which is the incremental cost effectiveness ratio for the project C. So this is how it is. And you can do this for this triangle, that is A and B. You can make a right triangle here, and here you can also make a right triangle, because this will be the status quo, and as compared to that, this is A, and this will give you this right triangle, rise over run. This will give you the incremental cost effectiveness ratio, which will be equal to 50 over 10. As you can see here, this is 50. So this is the rise, and the run is from 0 to 10, that is 10. So it will be 5. So you can make this triangle between A and B as well and find the incremental cost effectiveness ratio for project B. Now this method can have some limitations, and let's talk about those limitations. For example, the CEA should also follow the convention of CBA, which tends to include the societal benefits in the costs. So this is something that should be done. For example, if we have a situation where there is an expensive drug and that is produced to cure the schizophrenia, and it can have the effect of reducing the time of the patients which is spent in hospitals. Definitely this expensive drug will help them, and if they feel better, they will be visiting to hospital less, and the expenditure on that process of visiting hospital and doing all those things will be reduced. So in this process, the analyst might measure only the agency cost of enforcing the compliance. Whatever the agency, that is the health agency, has spent on enforcing this compliance of giving this drug to various people who suffer with this disease, that will be considered. But this is not the right thing to do, because there are other aspects that should be included. Because these aspects are the costs that are borne by the patients. Because the patients, they have to travel, and their travel time cost should be considered, which is the cost of their time that is spent in traveling instead of doing something else. And the cost of unpleasant side effects should also be included, because people can have some side effects with this drug. So that drug can cause some side effects, and these the costs associated with those side effects should also be included. Now the next thing is that the drug can reduce the productivity losses. Yes, people will be more productive. In addition to their improved health, they will also become more productive, and the losses that were there before due to this situation of health, they will be able to be more productive and avoid those losses of productivity, and that will also allow them to have more income, and their income will not be lost due to the side effects or the effects of the disease. So these are a few things that should be included in our cost effectiveness ratio. So effectiveness is there the way it was before, and we know that it's not monetary in nature. And the costs, they have been there before, the costs that are incurred by the agency, the state. But in addition to these dollar costs, the other social costs are there that we overlooked before. That is the travel cost to the patients, and also the family and friends costs that they face, because people will have to take care of the patients. So the friends and the family, they will also face costs. And there will be other social benefits as well, which should be subtracted from the costs, because they are benefits and they are not non-monetary. They are monetary in nature. So these avoided lost income due to the avoided productivity losses, they should be included in the existing monetary values, and they should be included in such a way that they should be subtracted, because we are talking about the costs in the numerator, and the benefits should be deducted from there. We did not add these benefits in the effectiveness because these are monetary in nature, and these are non-monetary in nature, because income can be easily measured. So you see, the cost effectiveness ratio is now adjusted, and this adjusted cost effectiveness ratio is much more representative of the actual situation when it comes to the societal point of view. So that's where the limitation of the cost effectiveness ratio can be overcome, and we can fix this by including other costs and benefits. So this was the diagram of the cost effectiveness ratio that also included the incremental cost effectiveness ratio, and this was the calculation of the CER and ICER. This was the interpretation, this was the introduction to ICER, and this was the diagram of CER, that is cost effectiveness ratio, the table of calculation, and this was the introduction, the two possibilities of ECR and CER, the introduction to CEA, that is cost effectiveness analysis. Thank you.